Just a very quick update on the state of the project. Viewer of this channel probably familiar with this board. This is the Spartan 7 by QMTech that I've been using so far for the project. I bought it for $30. And the reason I say so far is because I'm going to change that. But first, what's on this board? We have the Spartan 7, 256 megabytes of DDR3 memory, the configuration RAM, that's SPI flash device with the 16 megabytes. And then we have a power adapter, obviously, but we have a USB port, which is connected to a serial. So this is a UART and HDMI. So that was provided, of course, LEDs and micro switches. So that was providing us pretty much with most of what we needed. We still need to add to that in order for have the CompuStar system as a whole. We would need to add to that SD card, USB ports for keyboard, mouse, joystick, and I wanted a real-time clock. So other than that, yeah, that's the board. There are two problems with this board. First, as of today, it is unobtainium. QMTech are not selling this board anymore and have no plans of ever selling this board again. Definitely not for $30. And the second problem is that the Spartan 7, the XC7S15 board, which is this Spartan 7, is just too small for our needs. So I need something else. And guess what? I got something else. So this is the Artix 7, and it's the XC7A35T, and it has considerably more space on the FPGA than the Spartan 7. It also has this trick that allows us to fill it to pretty much 100% capacity and not suffer long generation times and timing problems as a result. So yeah, that's a nice option. Aside from that, it has two HDMI ports, one labeled in and one labeled out, or in, out, and out. We don't need them. We don't need one port. It has DDR3 256 megabytes, the exact same chip we have here, and it has configuration flash. I think it's this one, not sure, which is the exact same or compatible one to the one we have here. That's a Micron. That's some other company that Micron bought, which has essentially the same commands. So essentially, it's the same chip. Aside from that, it has two USB ports, which we can't use the USB here because it's wrong polarity, but we can use this one, which is a UART with the exact same CP2102 that we have here. So it's basically the same board, except it also has a camera port, which we don't need, Ethernet port, which maybe we'll use, probably not. It has an SD card port, which we'll definitely use. And it has a sensor, it has a temperature sensor and a 7-segment display and other stuff, which, okay, we don't really need it. Sadly, this board is considerably more expensive. It costs $130 plus shipment, which is also not very cheap. But for development stage, it has what I need. So for now, that's the board I'm working with. Now, since it has the same DDR chip and the same SPI flash, you would think that porting would be very simple. So, I mean, in theory, all we need to do is just update the pins that the FPGA is outputting on so that the output on the correct pins for this board rather than this board. But the difference between theory and practice is that in theory, there is no difference between theory and practice. So this is the project after switching to the new board, to the new FPGA. In actuality, it's about half the project. I cut it half in order to debug the problem that I'm just in a minute going to show you. But even so, we see that the usage dropped dramatically because the chip is much bigger. When we actually load it, however, we see there is a problem. This is running a mem test, and as you can see, the mem test fails. Our DDR controller is not doing its job properly on this new board. So right now, I'm working hard to debug this problem. Actually, I haven't started on this problem in particular. I'm still working on fixing the constraints. If we look at the design, we see a lot of check timing warnings, and it complains about ports that have no delay defined for them. So I'm working on fixing that. I've already moved all of the async ports to be declared as async and not requiring constraints. Well, not all of them, I see. But the DDR ports are the next to be defined. And then I'll have to figure out, if the problem persists, I'll have to figure out what it is. I do have a few leads. What you will notice here is that the program fills the memory with a pseudo-random pattern. It fills the entire 256 megabytes, and then it comes back and reads the memory back and checks whether it's still the same pattern. And what we see is that pretty much it never is. So none of the words we read are correct, and we're reading 32-bit at a time. However, what you'll notice is that some bytes are okay. In particular, the bottom byte of the 32-bit are always okay. DC, DC, 84, 84. Almost always okay. We'll see that every 4 sequences, we have a lower 16-bit that is all zeros. Now, this is very interesting. The reason it's very interesting is because the way the cache works with the SDRAM. The way this works is we're doing 128-bit transactions with the DDR, but the DDR has a bus width of 16-bit. So we're writing 8 16-bit words to the DDR. And what we see is that the first word we wrote reads back as always reads back as zeros. And for anything else, the lower byte of the even transactions reads back correctly. And we also see that the lower byte of the odd transactions read the same as the lower byte of the even transactions. So we see, so this is supposed to be 9C, and this is 9C. FF, FF, 83, 83. So we see that we have this shift. We're supposed to see 83DC, and we're seeing 83DC in the wrong location, and then 60DC. So this screams timing problem. This is almost definitely a timing problem. Because of the way the DDR works, loading values both on the rising and the falling edge of the clock, this definitely means that there is some discrepancy between when the DDR makes the data available and when we actually read it. Which, yeah, okay, I'll need to debug that, and hopefully it will not take me 3 months again. But I wanted you to see where we are and why there were no updates of late. So, thank you for watching. Thank you for your patience. And in particular, I want to thank my 10 paying patron supporters for their patience. I know updates have been sporadic of late, and I'm really, really thankful for you sticking with me through this. I'm really hopeful that updates will pick up very soon. Essentially, we have a few infrastructure projects that have a lot of work and little shown progress to show for them. And we're almost done with them. This move to the new board, it was one. Getting multitasking working was one. We still, ahead of us, we still have the USB, getting USB working, but that's a little far off right now. And aside from those, things should start to show results much quicker going forward. So thank you for sticking with me, and thank you for watching.